No.
Nothing? Okay. Then we finish, I should say, this part before. Let me go back to, I should say, the R. Okay, we are finishing, I should say, the linear model, which we created, I should say, yesterday, with two simple, I should say, observation, which we're just going to do that for this model. The first one, which I want you to also remember that to do that when you just work on your next coming project, is gonna be this code. We call that to observe. That's I just put the hashtag sign to observe the predicted values of height. Look at this one. Right now, I'm just coming here to say that. I just want to see the predicted values which I have done from the height. There are two methods to do that, especially when we just want to go to making the predictive models. We are just going to talk about that tomorrow. But right now here, there is one simple line of code which is called fitted. You see that? Fitted. Parenthesis, you get what? And you just, inside of it, you have to just put the name of the model which you have. If you have a question how to use that one, you can just simply write it like the help, as what we learned yesterday, and you just put the name of the functions there. Press Control Enter. If you're working with the R Studio, you see that here on the panel, which is going to be for the help. But as Laura, if you're just working with the R, you're able to see this one on, I should say on a new browser which pops up when you just run that command. Then you see that when you just write the fitted model, it's gonna be, it asks us, there should be an object inside the model. Look at, go to the help, the usage, it says that the fitted, and it also asks for one object type inside the parentheses. Our object is essentially the model which we created in the linear model, and I call that model. I'm just gonna put the model inside, and I'm just gonna execute the line by pressing Control Enter, and you see at the console, I have so many interesting things which is pops up there. The first thing, guys, that you see is gonna be, for example, you see, it's everyone see the line which I have here, huh?
Yes.
Awesome. You see this one, you see I have two rows for each value. I have, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, which this one is essentially, this is the number of the people which they are in our group. Okay, these are in our group. And now you see that, for example, woman number 1, woman number 2, woman number 3, all the way to woman number 15. And the values which we have there, which is 15.8.75, 59.33, these are essentially the predicted models that our model predicts for the women's height. This is not their actual height, that's the thing, your polynomial, which we learned about that last week in our math session, is predicting for these women. You see, that's what we call that the mathematics in action. This one, the fitted model, it shows the value which is predicted. The value for woman number 1, which is predicted, is 58.75. For women number 2 is 59.33. For women 15 is 72.83. Okay, but what is their actual value? Their actual value, it's just gonna write the actual women's height is gonna be this. You remember that. You just put the name of the women, you you press shift and number 4, which is gonna be the $sign, and you can just choose the word height. I'm just gonna run the code. Then you see that then you see that for women number one, we just get the actual height. The actual height, when you run this code, is going to be 58. But for women number one, on the last line, I have 58.75. You see, we are so close. For women 50, woman, I should say woman 15, your polynomials of degree 1, it predicted the value of 72. But for what do we have here is going to be 72. For example, for woman number, I should say for woman number 3, we have the actual value as 60 inches. But the prediction it produced, I should say 60.19. You see that? You see the differences between what your polynomials of degree 1, the model which you feed based on that, it's predicting, and what actually you are extracting from. Does it make sense, guys?
Yes.
You see that? And that's essentially what we learned on the math section when we talked about the polynomials. We see right now what it implies if we just use, I should say, polynomials degree 1. We see that we have predicted values, and we see that we have actual values. There is a difference. For example, the difference between woman number 1 and woman number 1 predicted, how much is that? The residuals, I mean the errors. The prediction was 58.75. The actual height of the first woman was 58. Then the errors which we have here, our model created is going to be, as for consistency, we just start with the predicted value, which is going to be 58.75 minus 58, which is going to be 0.75, correct? But in order to just find these errors, as I should say, as the very, I should say the last line of the codes we're just going to run to finish the lab today is that I just write the extract the residuals or errors committed by the model as a description. In order to do that, there is a simple line, residuals. You put the residuals, and you see that you have to fill this. As I said, if you do not know how to fill this line, you can just always remember, you can just put the residuals inside, I should say, the help function. Then you get, I should say, the required arguments that you have to fill this function with. For the model which we have here, it says that it should be an object, and the object which we have again is going to be the model that we created. Then now it seems that the line of this code is ready to be, I should say, to be used. Then the thing which I do, I'm just going to press Control Enter to execute the line. And when I execute the line, I see that, okay, for woman number 1, the difference, look at that, is going to be 75 minus 0.7571, which is the difference between this one and this one. In the R, the method which it uses the actual minus the prediction, and you see that because the prediction is slightly greater than that, that's the reason that you got the difference one, you get the minus. For women number 15, we get, for example, the difference, which is the residuals or the errors, is gonna be this. And you see that the sum squared of all these ones, it encapsulated into the squared sum of the residuals when you just run the summary of your lines. Okay, and now I should say we are pretty much done for this, I should say, for this tutorial of our methods. And also, if you are interested, let me finish the last code. That sometimes it's we finished the tutorials today for the lab by that. We said that the plot, the errors, that sometimes it can be used as a diagnostics for the model which you do. And remember, these individual codes, is going to be something that you're going to use that for these coming projects that you're just going to have. The thing which I'm going to do is this. I'm going to say, okay, I'm just going to plot the errors which I have done. In order to do that, I can just come here and the residuals which I created in the last model on the last code, I can store it into a single object. I call up that object errors. You see, I create a new object, which I call that error. You want to see what is error, you can just run the, I should say, str, which is the structures for the error, and it says that it is simply a number, an array of 1 to 15, and it contains these numbers. It's the thing which we have seen. That's an object which I created. And now you see that I want to plot it. I want to plot the errors. I'm going to put that in parentheses. And for the object which I put this there, I'm just going to put errors, which I created before. And I can just call this plot which I created. You remember it from the things which we learned from last week. Main, inside the quotation mark, the residuals of our linear model. And I'm going to run it, and you see this plot, which it shows there. Normally, you see that the plot which we have here, it starts from, I should say, on the x-axis. The errors which you have is something stands between, I should say, 0 to 15. It says the index, which it means that index is, for example, when you name the woman by the number. We have woman number 1, we have woman number 2, we just went to all the woman number 15. And that's why you see that the index refers to the number which assigned to the woman's. And also you see the errors. You see that we started, I should say, from minus 0.8 from the first woman, and we see that we just go all the way up there, which the maximum of the errors, which it was 0.4. And you see that we got exact the same minimum number of the errors which we had from the summary which we extracted from our linear models before we just go to the breakdown. As you will see that for tomorrow, and we're just going to do the lab sessions for right now, the plot, when you just make for the errors, when you are done with the modeling, if it follows the patterns, for example, you see that the errors which you have here, it resembles to a polynomial almost, which it means that the model which you have created is not gonna be a perfect one, because our assumption is that, please remember this one, it's gonna be the golden key which we learned from today's session. And it's not gonna be like that, that when you plot the error, plotting the error, it serves as a diagnostic tools for your model. If the errors which you have plotted, it follows a pattern. For example, you see the pattern which is here, you can think of it as what? As a polynomial, which we talked about that yesterday, that with the leading coefficient, which is going to be minus, it's upside down. Then in that sense, it shows that the model is not a very good one, because our golden rule is this: the plot of the residuals of your model should not follow a pattern. It should be random all over the places. But right now here, we see that we can just pick up our pen and create, for example, you see that, for example, we can here pick up our pen and, for example, create a polynomials, almost a polynomials, which is skewed a little to that errors there, which it signifies to us the models which we have created, although it encapsulates a good variations between those 15 women. However, in terms of the diagnostic method which we have used, it may not be a perfect model then. Tomorrow when we come back from I should say, the next tutorials, which is going to be much shorter than the ones which we had today, is going to be about how to fit these polynomials, how to fit this model based on the polynomials of degree 2. And we see that when we just run the errors and when we plot those errors, we do not see these kind of patterned shaped, I should say, residuals on our, I should say, on the plane of the things that we have. And essentially, tomorrow we have a very interesting thing to do. Our lab session for today is done. Then please ask me if you have any questions or if you have any problems to run your codes then. Let me stop the recording.